All right, number 36. Okay, so this is very similar to the last problem, except that it's a division problem, which is a, as Mrs. Barnett coined, same, change, flip scenario. Same, change, flip. Okay, so what exactly does that mean? That means you keep the first fraction exactly the same. So that's what we're going to do, n plus 4 over 8n plus 32. We're going to change the division to multiplication, and then we're going to flip the second one completely. So this becomes 3n plus 15 over 1. And then what we want to do is we're back to the same thing we were doing before. We are going to factor each individual numerator and denominator and see what cancels. So these are actually really easy. In the top right, 3n plus 15, we can factor out a 3 and we're left with n plus 5. In the bottom left, we can factor out an 8 and we're left with n plus 4. And then it's just a matter of going through and seeing if anything cancels out. So I can definitely see an n plus 4 that cancels out, and we're left with 3 times n plus 5 on the top and 8 on the bottom. Okay, so that is D. Okay, keep it moving. Keep it moving, keep it moving. I have a challenge going for myself. We have about 20 minutes until school starts, and we have 14 problems left, 13 problems. I think we can do it. I think we can do it. Okay, you all are along this ride with me. All right, so same change flip again on the next problem. So I'm just going to go straight into the changing flipping piece. Okay, so it starts out as 2a minus 4 over 15a squared. It starts with divided by, and then another fraction. I'm just going to straight up change it to times, and then flip it. So 3a squared plus 8a minus 3 over 6a squared minus 14a plus 4. Okay, that's good. Now, so what we want to do is, again, go through and see if we can factor anything here. So I'm looking right now out, I'm doing the same thing that I hope you all are doing, which is assessing each numerator and denominator, seeing if anything can factor in any way. So in the upper left, I can factor a 2, and I'm left with a minus 2. Bottom left, not so much. That is what it's going to be for now. It might cancel with some stuff later on, but as far as factoring is concerned, it's done. It's good. Okay, upper right, we have our lovely diamond. I know how much you all love this. So 3 times negative 3 is negative 9, and 8 in the bottom. Two numbers that multiply to negative 9 and add up to 8, that would be 9 and negative 1. Make sure you bring the 3 down with the a so that you can reduce anything. This one's reduced already, but this we can actually divide a 3 out, and we're left with a and 3. Bottom, let's see, we have a 2 that can be factored out of everything. We're left with 3a squared minus 7a plus 2, which, you know what, let's make some big parentheses here. Ooh, there we go. That way we can do a diamond all within this parentheses. 3 times 2 is 6, negative 7. So two numbers that multiply to positive 6 and add up to negative 7 are negative 6, negative 1. And again, make sure you bring the 3 with the a so that when you can reduce, that's as reduced as it's going to be. And then this one, if we divide a 3 out, we have a and negative 2 left. Okay, so some of you might be able to look at this already and go, okay, I can see that right now, right off the bat, a couple things are going to cancel, like the a minus 2s and the 3a minus 1s. But for the sake of organization, you all know that I tell you organization is so important with a lot of these math concepts that we learn. For the sake of organization, we're actually going to go through and write out what we're left with. So this we have 2a minus 2 and 15a squared. That didn't change. This one ended up becoming a plus 3 and 3a minus 1. The bottom we had a 2 here, and then an a minus 2 and a 3a minus 1. Okay, canceling time. The 2's cancel. The a minus 2's cancel, and the 3a minus 1's cancel, so we're left with a plus 3 over 15a squared. Oh my, I just realized that was a little far down. Ooh, that one was fun. I'm such a math nerd. You all know this about me. Okay. I like doing problems like this. See, the thing that is nice about math is that of times there is one right answer. You know, sometimes life can be very complicated and you get into situations where there are multiple right answers and it can just get very confusing and very muddled. So math is one of those very definitive things. There's always at least, there's an answer. It may not be one, there might be multiple, but there's a way to get there. It's very, okay, we've gotten off track. Okay, here we go. And I'm going to lose my challenge to myself. All right, this is so complex rational expressions. We have a fraction within a fraction. This is another same, change, flip. So the numerator stays the same. The big fraction line changes to a multiply, and then we flip the bottom. So we get x over 1. And then, if there's nothing that can be simplified, we just go and multiply straight across. Or, as we like to call it in Algebra 2, we smash them together. X squared times x is x cubed. 3 times 1 is 3. The end. That one was easy. And fun. Again, I'm not going to lie. I think you all would be, you're much better off knowing that you have a math teacher that's kind of a math nerd, as opposed to one that does not like math at all and is doing it just because they have to or something, you know? So, embrace that. Okay, here we go. Next, another complex fraction. We have talked about how these problems are every math student's dream problem that you love and can't get enough of because you have fractions within fractions. Okay, we're going to look at the numerator and the denominator separately. In the numerator, if we want to get, basically we have to get those two fractions into one cohesive fraction. The way we do that is we need a common denominator. So if I know that if I multiply the 3 by another 3, I will get a common denominator of 9. So I'm going to do this all in one very big step here so that, again, I want to make my challenge. 5u plus 4 times 3 is 12. 5u plus, let's do this over here because this comes out to 12. This comes out to 9. Remember, when you have the same denominator, you can add the tops together and keep the denominators the same. So 5u plus 12 on top, 9 on the bottom. Cool. Now we want to do the same thing down below. So, common denominator of 16. So, we end up getting 4u plus u over 16. Now, we're going to do same, change, flip, except I want to make a note that 4u plus u is 5u. So keep that there in your head. All right, same, change, flip. Numerator stays the same. Change the division to multiplication. And then flip the bottom so we have 16 over 5u. And do we have anything that can be reduced? I know a lot of us are looking at those 5u's and are very, very tempted probably to do something with those. But I think we're out of luck. Sucks. I like canceling things. That's alright though. Okay, so we end up with 16 times 5u plus 12 over 45u. Yep, still nothing. Still got nothing. So that would be A. Now they actually multiplied it through, but it is equivalent to what we got. Alright, number 40. We can do it, we can do it. Oh, but these are fun. Okay, here we go. X plus 1 over 3x squared plus 11x plus 6 plus 2x plus 3, 3x squared plus 11x plus 6. Okay, adding and subtracting rational expressions, which are fancy fractions, we have to have the same denominator. If we have the same denominator, we can just add or subtract, depending on what we're being asked to do, the numerators together. So we have the same denominator here. So what we're going to do is we're going to add together 1x plus 2x is 3x, and 1 plus 3 is 4. And then we have 3x squared plus 11x plus 6. You always want to go back and simplify, see if there's anything that can cancel. But, you know, what I want you to be doing is thinking about in your head. 18, 11, 9, 2, 3x, 3x, which this reduces to x over 3. So those are our factors. So even if we reduced this to 3x plus 4 over x plus 3 times 3x plus 2, we still couldn't cancel anything. So again, your test, does not put it in factored form if it cannot be factored. So use that as a good test-taking strategy. Kind of check as you go. So this ended up being A, okay? I have run out of paper here. Okay, here we go. All right. We're good. We're good now. We have more paper. Okay. N plus 2 over 8n minus 12 minus n minus 4 over 8n minus 12. So I do hear, I don't know if you guys can hear it, but there is somebody knocking on the door, and I told my students yesterday that I was making these videos for them and that I probably would not be available, but maybe they didn't hear me say that. Okay, when we are subtracting, we want to make sure we distribute that subtraction sign to everything to the right of it. Okay, so let's see. When we go through and combine n minus n, the n's, yay, I cancel, something that canceled. 2 minus negative 4. What do you think in your head? 2 minus negative 4. That is the same thing as 2 plus 4, which is 6. So it's 6 over 8n minus 12. And again, you want to go back and see if you can simplify anything. If I look at the bottom, I know that both 8 and 12 are divisible by 4. So that's what I'm going to do, 2n minus 3. Let's see. And then I want to reduce the 6 and the 4 to 3 over 2. So we get 3 over 2 times 2n minus 3. And again, their solution, they actually multiply that through to get 4n minus 6, but it means the same thing. You don't need to go back and redo that. Okay, here we go. 42. Oh, this is really going to slow me down, I can tell. M plus 2. And this is actually a good test-taking strategy for you guys. If you see problems that you know are going to take you a little bit longer than others, go back to them at the end. That way you're not super rushing on a bunch of problems that would have been much easier if you would have just done the easy ones first. I don't even know if that made sense. I'm still tired. It's very early. Okay, here we go. So, what we want to do first here is we want to, we have to have the same denominators, and unfortunately there's just no way around this. We have to multiply this first one by 3m minus 3, and the second one by m plus 4. Because remember, those are units. We can't not do that. We just have to do it. Okay. We just have to, this one is going to be a FOIL or box. Okay, so when we FOIL or box, m times 3m is 3m squared. Negative 3 times m is negative 3m plus 6m minus 6. Okay, remember I said do not, really do not go through and multiply out the denominators, because if the goal is to simplify completely at the end, by the time you're at the end, you're like redoing things that you wouldn't have had to do otherwise. Alright, so 3m minus 3, m plus 4. Alright, so let's go through and let's combine any like terms that we have here. Okay, so on the top we've got we've got a 3m squared plus 4m squared is 7m squared. Negative 3m plus 6m is 3m. 3m plus 16m is 19m. This looks fun. And then a minus 6 on the end. And on the bottom we have an m plus 4 and a 3m minus 3. Now, I notice on the bottom that I can actually factor a 3 out of this 3m minus 3 to get 3 times m minus 1. So I want to do that. 7m squared plus 19m minus 6. I'm actually going to move the 3 up to the very front. Ooh, whoops. I lost my pen a little bit. Okay, m minus 1. All right, let me stop there and look at the answers and see if there's one that matches this. Because again, you guys are very lucky that you have a multiple choice test. You would want to go back and see if there are, if you can factor this using the diamond, but check as you go. Again, multiple choice is very nice in that way. All right, so we're going to move on. I'm going to stop there because that's all the factoring madness for now. Rational expressions, and we'll move on to the next video.